this presentation I'm going to be looking at is going to be talking about structural equation modeling with Laverne in R. So what you are going to be expecting from this particular presentation, you're going to learn about structural equation modeling. So what structural equation modeling is, which problem do we tend to solve with structural equation modeling, how do we implement this particular type of analysis inside R, and what are the benefits of using it, and also how we can also interpret a particular analysis which we have already done using structural equation modeling. So I'm going to be the one presenting this particular presentation. My name is Adejuma Ridwan Suleiman. So I'm a data scientist at Business Data Laboratory, and I'm also a statistician and a Udemy instructor. So I'm going to be the one presenting this particular presentation. I'm also a technical writer on Medium. So what are the contents of our presentation? First of all, I'm going to be giving an introduction to SEM. So I'm going to be introducing you to the concept of SEM, what SEM is all about. That is structural equation modeling. What do we mean by structural equation modeling, and how better is it compared to other models in statistics? And also, I'll be explaining the key concepts in SEM. So these are some particular key concepts which are peculiar to SEM analysis, which is going to enable us to be able to know how we can interpret and with our analysis in SEM, and also how we can explain what we have already done inside our analysis. So I'm going to be talking about most of these key concepts in SEM. And also, I'll be giving an overview of the Laverne package. So the Laverne package is a package in R which allows you to be able to perform SEM analysis. So just like other packages in R for performing other statistical analysis, we also have the Laverne package, which is peculiar for just performing the SEM analysis. So I'm also going to be talking about this today in this presentation. And I'm also be talking about model evaluation. How do we evaluate our model and know if our model is a good fit or not a good fit for our data? These are some of the things I'm going to be talking about under model evaluation. Then next, I'm also going to be conducting a case study, an example of how to perform a SEM analysis, and also how we can also interpret this particular SEM analysis using all what we have already learned in today's presentation. So these are some of the things we're going to be talking about today. And finally, I'm going to conclude by a summary. Give a summary of all what we already discussed in today's presentation, and also give it some time for a Q&A. I'm going to be giving an overview of SEM. So what is SEM? So SEM is actually a multivariate statistical analysis. And when we mean a multivariate statistical analysis, it means that it's an analysis that is used for analyzing a data where we have more than one variable. So any situation where we're having more than one variable, then we call that a multivariate data. So we're having more than one variable inside that particular data. We're going to be studying all those particular variables. You can have 2 variables, 3, 4. So these are multivariate statistical analysis. It's used for describing the relationship between latent and observed variables. So I'm going to be explaining latent and observed variables with time, but just know that latent and observed variables are the 2 major types of variables which we deal with in SEM analysis. Whereby latent variables are variables which we can't observe, and observed variables are variables which are observed, right from the name. So this is just a summary of what SEM is, a multivariate statistical analysis, because it deals with analyzing of various variables inside a data, and for finding the relationship between observed and unobserved variables. So observed variables can be variables which you can observe, or they have units of measuring, and unobserved variables are variables in which there's no way of actually measuring it. I'll give more hints and more light on it later. I'll shed more light on it later on. It is an extension of multiple regression analysis and factor analysis. So multiple regression analysis is a type of analysis in which you use various independent variables to predict a particular dependent variable. So you are trying to get the result of a particular variable using other variables. So this is what we know as regression analysis. So what do we understand by multiple regression analysis? Well, multiple regression analysis is a type of statistical analysis in which you use various independent variables or various predictor variables to predict a dependent variable. So you are using various variables to predict one particular variable, either from various studies which you have already known from past studies, or based on a hypothesis. You know that, okay, a particular variable is likely to predict one variable. So this is known as multiple regression analysis. And also have factor analysis, where factor analysis is where you reduce a set of variables or numbers of variables into a smaller number of variables. So let's say you have some variables which are sharing various commonalities or similarities, or have various relationship with each other. So you can reduce those particular variables, let's say for example 10 variables, into 2 variables or 3 variables. So this is actually what is known or defined as factor analysis. So this particular type of analysis which I'm talking about now are both extension of structural equation modeling. So extension of most of this analysis is what we have, as because we perform most of these things inside structural equation modeling. We have multiple regression analysis and also have factor analysis. SEM is also used in various fields, but most of the fields which are usually known for the use of SEM is social sciences, where they test models where theoretical constructs such as attitude, beliefs, and values are measured directly through multiple items. So in social sciences, we have a lot of theoretical constructs which cannot actually be measured, let's say with a particular value of physicality. So these are usually used as taken as latent variables, which I've explained earlier on, something that you can't observe and are measured directly through multiple items. So some of these items can actually be measured. Then this is where we now bring about theoretical constructs such as attitude and belief. So we have a lot of variables which can actually measure, but we know we don't have a way of measuring attitude and belief. So we use those set of variables to now create a measurement for attitude, belief, values, or other theoretical constructs which are in social sciences. So social sciences use SEM analysis a lot. They also have in psychology. Psychology also, they use SEM analysis where they have variables which are latent, such as personality traits or intelligence. These are measured through questionnaires. So they use questions as the variables to measure a particular type of latent variable. That is happiness of an individual now, for example, can be measured through a lot of items or a lot of questions. So these questions are now modeled to the latent variable. So this is where SEM analysis now comes into play. So what are the benefits of using SEM analysis? So the first benefit is that actually SEM analysis models complex relationships. So at times some relationship can actually between variables can get so complicated that other statistical models cannot handle it. So this is where SEM analysis comes. So when you have a very complex model or a complex relationship between various variables, then SEM analysis can be able to handle that type of problem. So it also provides estimates for direct and indirect effects. So we have direct and indirect effects whereby a particular variable is influenced on another variable through another variable. So this is what's an example of indirect effects. I also have direct effects where a particular variable influences another variable directly without any variable coming in between them. So we'll also explain direct and indirect effects later on, but these are the kind of problems that SEM analysis tends to tackle. It provides estimates for such relationships. Then we also have the ability to handle missing data and provide model parameters in the presence of missing data. So unlike other statistical models which can't actually be fitted well with presence of missing data, so that is not the case in terms of SEM analysis, because in SEM analysis it's able to handle missing data. Whether you have missing data or not, SEM analysis can handle it and give you accurate estimates regardless of whether you have values that are missing inside your data. So what are the limitations of SEM? Also, like other statistical models, they have their advantages, they also have their limitations. So these are situations whereby they are not actually a good choice of use. So in terms of SEM analysis, it usually requires a large sample size to obtain reliable estimates. So if you want to get estimates which are making sense or which are going to be useful for you in terms of interpretation, then you need to have a very large sample size, which sometimes in the real life is very difficult to get a large sample size. So this is one of the limitations of SEM. It also requires a well-specified theoretical model. So when we talk about a well-specified theoretical model, it means that you need to make sure that any model which you want to construct, that is before performing the SEM analysis, or you want to hypothesize a particular model, you have to make sure you have looked at previous studies and see how the kind of models that have been used in that particular data. And also you need to construct a model such that when you have already fitted your SEM model, you are making sure you are going to get a reliable estimate and accurate parameters. It is difficult to learn in the sense that you need familiarity with sometimes advanced statistical concepts and also familiarity with statistical software or even advanced statistical software to perform SEM analysis. This is one of the reasons which makes R language a very good choice of performing SEM analysis. That way manipulate the relationship between your variables to make sure you come up with the best possible model fit. So what are the applications of SEM? So SEM are applied in various areas of life, and I've already talked about SEM being applied in psychology, applied in social sciences, education, and business. So in terms of psychology now, we have some kind of latent concepts such as attitude, beliefs, values. So these are kind of things which one tends to measure in psychology. Depression, a lot of these in psychology are usually SEM analysis is usually applied to be able to analyze these variables which are latent causal and cannot be observed in real life or in real sense. So SEM is actually used in social sciences to measure that we can have variables such as social support, the kind of things we actually measure in social sciences using SEM. And so in terms of education, to know a particular student's learning outcome, to measure learning outcome, performance of students, performance of teachers, we also use SEM analysis to handle things like that. We also have customer relationship, which you in business can measure customer satisfaction, customer relationship. Such variables are actually measured in SEM. So these are just some of the few places where SEM are actually applied. SEM can also be applied in health sector. Also other sectors, SEM analysis is also applied.